All right, everyone, welcome in. Thank you for joining. I'm so excited for yet another session. This is going to be great. Before we get started, let's go over our rules one more time, everyone. Just as a reminder, out of respect for our speaker and our fellow participants, we're going to remember to keep our microphones muted and not to unmute at all during the session. If you have any questions, comments, please feel free to leave them in the chat. We ask that you keep your questions related to the content that's being presented. Who knows, if your questions are a little too ahead, it could be answered later on in the session. Our team is here to help you guys with any questions you have. We'll be around. Another thing to mention, please make sure you leave your cameras on out of respect for our speaker. It's nice to make sure he has an audience to stare at, and we want to make sure he feels involved. All right, everyone, we're going to go ahead and get started as usual. So today we have another absolutely amazing session. We are joined by Mr. Arun Giri. Arun is the head of platform engineering and lead enterprise engineer at Union Pacific Railroad. And today he will be leading a session on data meshing. So Arun, the floor is yours. Thank you so much for joining us.
Thank you, Yasmina. Good morning, all. I'm not sure which time zone you guys are in, so I'm going to say this is morning for me. So good morning, good afternoon. Hope you guys are having a great day. Thank you for joining this talk. Really happy to share kind of our learnings in the journey. And like Yasmina said, if you guys want to keep this interactive, ask me questions, pause. I'd be happy to, or we could do. I'll give you enough pauses and breaks during section changes, and you can ask questions, or we can have all the questions at the end. Either ways works for me. So don't worry about disrupting me. I've told this story so many times, okay, it doesn't matter. Whichever way you guys want to go, we can go. So let me put this into a PowerPoint mode. Give me 1 second. Before I kick this off, my name is Arun Giri. So I'm a lead enterprise engineer and then the head of our platform engineering group here. I work for Union Pacific Railroad, which is one of the largest railroads in North America. So the problem, and then the solution of a data mesh is kind of using Union Pacific as the problem platform to describe the solution. All right, so I'm going to use a lot of perhaps examples from our company, so it kind of makes it real. Like, okay, so why are we doing this? Why is this journey this big? And pause, ask me questions, and I can help you translate to your industry, like how it might map to your industry. All right, so let me get started. Union Pacific owns and operates about 32,000 miles of rail network. Right, that's we fully own that network, and we own and operate this. Now, with it comes lots of challenges, right? Like if you think about it, we have 32,000, about 30,000 employees working on this railroad. We thousands of locomotives online, hundreds of thousands of cars, like rail cars, online on our network at any given point in time. And we literally haul about 35 to 40% of all U.S. exports, right? Like on our network. So it's a fairly large logistics operation, like a very, very large logistics operation. So it's very complex. So dealing with this complexity obviously means that we're heavily automated. We rely on technology a lot, and so we are a data-driven operation, and so that's kind of the background. So I won't bore you with Union Pacific Railroad details. So since this is more about a technology talk, so let me jump into like why you guys came here, right? How many of you think that you have data silos in your organization today? Probably all of you, right? Like any company, any company which is been around for more than 10 years has data silos, right? The way I describe data silos is, transactional systems produce data, right? And so you build transactional systems which owns and operates that data. Now, and you have many transactional systems in your ecosystem in your company, right? You'll have a financial systems, you'll have operations systems. If you're in the manufacturing, you have a planning system. If you're in transportation logistics, you'll have a planning system, transportation management systems. These are all transactional systems. It allows you to run the business. So we call them run the business systems. You'll have plenty of them. You'll have back office systems, which does your payroll, your finances, and marketing could have its own system, right? No matter whether it's a SaaS product or a homegrown product, it doesn't matter. They all they operate on data. They create data, they own data, and and they produce a lot of that. Now, the real value of a business is to move forward, right? And you want to move forward, you want to actually tie all of these data which is locked in your silos together. Like that's where you can do analytics. You can't do analytics on a single silo. You want to bring a lot of these data together to do analytics. So that's the problem statement. So my talk is really about how do you get rid of this, like an approach to get rid of data silos, and unleashing the kind of the power of all the locked in data which you have in an enterprise, right? This is a quick marketing slide, obviously, right? I won't dwell on this too much. Like this is North America defined in one slide. We have, if you put there are 7 Class 1 railroads in North America, in like US, Canada, and Mexico. And we own and operate together like 140,000 miles of rail network, right? And so you can imagine the complexity of these operations, right? Like we literally move almost all freight moves somewhere around, touches a rail network at any given point in time, and that is like nearly, if you just looked at the rail operations, 40% of intercity freight use this mode of transportation. So if you live in North America, like almost it's guaranteed that 70% of what you have in your house, something, or whether it was material to build your house or something which is in your fridge, was touched by one of these railroads, and we probably have a huge share of that thing. So it's a huge complex operation which brings these things together. So we operate with a lot of data. So I will talk about our problem, and I'll help you guys translate this. Like, the principles are exactly the same, whether it is in the logistics domain or you're in the manufacturing domain or in any other transportation. It doesn't matter. Like the principles are the same. So most people, if you think about truck and rail, when people think of transportation logistics, most people think of production happens in a facility, and trucks come and pick up, like, the finished goods and then move it to the warehouse, right? Or in a very simplistic thing, well, we might be rail connected. The production facility is connected by rail, and we put things into a boxcar and then moves to a warehouse. Well, logistics is not that simple. What it is for us, we have a complex network which we navigate, right? Like trains don't go from point A to point B, from production to warehouses to distribution centers. We switch. So if you think of each of these cars on a train as a passenger, and a train as the closest analogy is a flight with passengers on it. You want to get from destination A to B, you probably switch planes, right? Like you end up in another intermediate city, You get off this plane, you join other planes, and the operation for a rail is exactly the same. We load up, we build a lot of cars, and a 100-car train can go into one of these sorting yards, and it sorts into different trains, and we move them to different destinations. And so the assembling and disassembling of this trains happens all the time before something reaches a destination. And you can start imagining, like just the way you can imagine in large airports where you would come, lots of passengers get off different planes, go mingle, and change planes. It's exactly the same way. Cars come into these facilities, and we sort them, we put them into different trains, and they reach different destinations. So it's a very, very complex operation. Now, if we want to boil it down, like our biggest problem is operating efficiency. Right? These assets which we have is super expensive, right? We only have at the very high level, we only have 5 assets. Our employees who actually run and manage the operations. Rail cars, that's our asset, which actually moves the rolling stock, which actually moves the freight. Locomotives, very expensive pieces of equipment, which powers these trains. Terminals and yards where we sort things, like containers come, we put it on cars, or cars we had to switch them into different trains, and these are complex operations. And then the track capacity, it's called the liner road capacity, which is like we have 32,000 miles of rail network. It doesn't mean that like door to door it's connected, right? Like, so we have a complex network which we have to manage. For us, optimizing these 5 assets is the holy grail. That's what we're constantly striving towards. And you can translate to any other business. You would have your key assets, and optimizing and making them more efficient is the name of the game, right? Like that's where the costs are, and that's where your growth opportunity as a business is. So it's 2 simple things. So for us, it's these 5 assets. So what does that mean to us? Like, okay, what does it mean? I'm quickly walking down to like, okay, all of you are here for a data mesh talk. So I'm jump starting this quickly to say, you know what, you're here to listen about how do I do advanced analytics, right? So this is kind of Union Pacific's like spectrum of advanced analytic use cases, right? Analytics is a maturity model. Beyond the foundation exists because transactional systems produce a lot of data. They run the business systems. Now, the next set of things which happens, which we do with data when we kind of break the silos out and we bring them together, we want to know descriptive. The descriptive use cases, like basically we want to we are usually asking questions like, what happened, right? Why did this derailment happen? Why did we miss a connection, right? Like it's kind of looking back in the rearview mirror and asking the question, like the root cause question, that's descriptive analytics. And then we go into kind of a diagnostic mode. Well, why did it happen, right? So what and why are 2 separate things. Like we want to understand like the actual root cause. Like, something occurred. Like we've been missing connections. We've been missing, ETAs for our customers. Like why? Is the answer is sometimes like, okay, maybe there's too much dwell. There's the switching is taking too long at a terminal, or a certain portion of our track has the congestion. There's a capacity problem, or we may not have enough the right power, like the right locomotives powering the right trains. Things like this. We might be hauling too much tonnage. Like, there's a lot of reasons. Like we want to know why did it happen, right? Well, the next 2 sets of maturity is where the kind of the holy grail is. Like, can we predict some of these problems, right? Like we're collecting a lot of data. Can we actually predict and prevent some things? Like before a derailment occurs, can we predict safety problems, right? Or can we predict, like, if in the previous use case, like, well, we kind of discovered the root cause was a congestion or truck capacity. Can we predict that you're going to have a truck capacity problem? That's predictive, right? And then the prescriptive, like, can you prescribe a solution? Like, don't tell me you're going to have a capacity problem or you're not going to have enough power to power these trains. Can we come up with solutions like, okay, maybe you need to slow down something, maybe you need to reroute this differently, like, a different network plan. And so that's prescriptive. Now, the more you are to the right of the spectrum, the more value there is, right? Like, that's the holy grail. Like, we're all chasing, all of you, the people who are on this call and listening to this talk, like, that's the ultimate goal. Like, for all our businesses, the holy grail is yes, how can you quickly move to the far end of the spectrum, like get really prescriptive. That's where the whole efficiency is. That's the holy grail, right? I'm going to pause here for a second before I jump in. Like, is there anything which you guys have and you want me to address as I go on with this talk? Is there something, topics you want to hear? Like, I tried to set up a big macro level problem so I could walk down kind of what we've done and where we are going. If you guys want me to map it to something, just, I'll pause here for a few seconds if anybody has a question before I move on. All right, I'll keep going then. Feel free to pause. I think, there's questions on the chat, is it? Sorry.
Yes, you do. Would you like me to read it out to you?
If you can, please, because both my screens are occupied. Like, if you want to kind of curate the questions and just ask me.
Yeah, of course. I'll be taking care of it for you. So Anamol asks, how does optimization actually work in this field?
Good question. So, all right. Optimization has two pieces to this puzzle. One is you need to have enough data collected and curated and sanitized, and you make it into usable fashion, so that you can actually elicit some patterns out of this, right? Optimization for us. Let me make it more concrete. How do I optimize the usage of our locomotives? Each locomotive costs millions of dollars, right? And we have thousands of them, right? Like, so obviously that is a very costly asset, and we can't keep buying them. So let's say that our business is growing, as most businesses do. We want to do more with less. How do I optimize the usage of my locomotives to run more trains? That means I have to now take out either the places where, like, it's where it's not utilized, right? How do I optimize its utilization? How do I optimize the capacity which it brings? So some of the questions, some of the answers to this is classic OR techniques, and then you also have to think through. All right, once you kind of walk down the spectrum of four things, like, okay, if I'm using the same amount of locomotives and I want to do, like, run 10 more trains on this, I have to now reduce the time of switching so that the locomotive which is powering some other train is available to run this next train. Now, it has a small set of butterfly effects on this network, right? So it's very large. So what we do is we have algorithms to do power planning, and so we kind of predict, like, where a certain locomotive is needed, and then we start tuning it. We predict if we have a capacity problem, or we predict that maybe we can run this train with X set of power, when I use powered locomotive, sorry. And now I have to now, maybe I can use one less and I would still achieve the same tonnage. And so these are all calculations which are happening always, all the time. And so power planning is one of the optimization techniques. There's several algorithms. Like most of them are classic OR techniques, which we apply to these. And so maybe we can plan the consist, like the makeup of a train, in a slightly different way, so it requires one less locomotive. Or on the flip side of this, we could say maybe if you reduce the touch, like if we can make this train like put all of the cars which go to a certain destination and not make cars switch in a yard, that reduces time, and that allows us to actually use the same locomotive, because we took out 24 hours of time. That means that the locomotive is still available to run some other trains, right? So these are different techniques. Let me walk you through I can answer some of those questions as we get to the middle of this presentation. But for now, was that an okay explanation? Did it resonate?
Thank you.
Okay. All right. So my talk, it's a catchy, okay, a markety title here. It says, most of us on our maturity model or in this red box, like the descriptive use cases, perhaps to some extent we do diagnostic use cases, right? So I call that the red and the yellow boxes swivel chair analytics, because it's always looking in the rear view mirror. It kind of answers the history question, like what happened and why. It doesn't tell you about the future. So the reason we use the word swivel chair is like, okay, I'm sitting kind of in a comfy chair and then pontificating. Oh yeah, that happened, right? I mean, it uses a lot of data. It's complex set of analytics, but it is still about rear view mirror, right? Now, once you have, like, how do you get from that to the right hand side? How do you get to a prescriptive model? Now, that's the data mesh journey, right? Like, so moving forward, like, how do we get from this wheelchair analytics world to deriving value from like actual data products? And I'll define what they are. And the journey is, which you have to undertake, is the data mesh journey. So don't take this as an architecture picture, but it's a very conceptual picture. If you guys pause and think about your companies, this will resonate. Most of our legacy companies, companies which are have lots of run the business systems, will look like this. A siloed, the backend systems, the run the business OLTP systems. I mean, that's what the business users interact day in, day out. That's your run the business. And then analytics is usually an afterthought, right? Like, analytics is not something which most people think about on day one when they're building systems. It usually comes much later in the journey and the maturity. And here's what usually happens. People build an ETL system, extract, transform, and load into data warehouses, right? You can use all kinds of data warehouses, everything from Oracle data warehouses, Teradata, Informatica. Like, you pick, Snowflake. You can pick any data warehouse out there, and data lands in the data warehouse. It's obviously that is not enough, right? And a lot of other integration happens because you need lots of system of record. Like, okay, I need my employee records and I need my location records. Like, the things which are like fundamental to your business, those domain concepts, static domain concepts, that's your system of records. And you join them all. and you start creating data marts for a certain problem, right? Like it's very problem specific. Today, if you looked at it, then if you guys reflect back on what type of systems, analytic systems you have, is very problem specific. You can't really reuse the same data products for different things. You have to completely do this pipeline again, right? You have to create another model for the next problem. It's kind of tailor-made to answer like one or two questions, and that's it. If you want a third question, like you got to rewire this thing, create new data marts, and go through this transformation process, right? And it's fairly expensive. It used to work. I mean, I'm not saying it's broken. I mean, like if that is where you're deriving value, it's perfectly fine. We were that way for the last few years, and it's perfectly fine, right? Now, as soon as you start moving to the right and then say, well, I want to now get more efficient as a business. I want to grow. Like, and data is the foundation for my growth. As soon as anybody starts making those statements, then this system doesn't work, right? That's when people have to start investing. That's when people have to figure out, well, what's the journey to move from this model, which is kind of fairly look in the rearview mirror model, to the future. Like, how do you structure this? We are a data rich and insights sport. Like when we started this journey, right? We could do almost all of the things which I said on the spectrum, but it wasn't in an efficient way. It wasn't very efficient, right? It used to be very costly. So we were very data rich, and we would do the first two parts of, like, I could do descriptive analytics really well. I could do Tableau reports, and we could give reports and key metrics to the business like that. The data was well curated in data warehouses, but that was the extent, right? It was getting very expensive to do the rest of it. This is kind of our snapshot, right? And most of you probably can identify with this. The numbers might be different, but it look the same, right? Any questions on this before I move? No,
You
yes,
do
okay.
have a question, actually.
Oh,
From Rima. Rima wants to know, can you dive deep into the ETL processes? She was hoping to learn about what sort of data preprocessing goes on during this step. So Power BI versus Tableau, which tools?
okay. All right. I can go in a little bit on that. Okay, so let me get to that ETL question when I get to the actual describing. Like, here's the short answer to this. If you want to get to the prescriptive and predictive analytics, then you have to flip that ETL to ELT. Like you cannot sustain this with an ETL model. And so I'll explain why. In a short while. The second thing is, I'm not answering your question directly, simply because the two tools which you described, like the Power BI, Tableau, those are, to me, they're insights exploration. It means that it comes like towards the end of this pipeline. If you think of this, data is moving in a pipeline from left to right. Those two tools are not in the beginning of this. It's not helping you curate the data. It's not helping you massage the data. It's actually helping you create reports, right? Yes, you're massaging the data to some extent in those tools. You're caching them, and you're rearranging this in a way to produce some useful reports, but you're not doing any more of pipeline processing. And that's one of the and I like it that you asked me the question, like, okay, Power BI and Tableau, lots of people use this for ETL, and it is. And my recommendation is, like, as we move forward, like, you have to flip this. You have to like decouple the transformation and loading completely. You have to do an extract, which is very different, loading, which is different, and a transformation at the edge. Like, so that's the whole story. So I think your question was like, how do you do this transformation? I'm saying don't do it. Like if you truly want to move this to the right in the spectrum, you had to start thinking about ETL, stop thinking about ETL and think about ELTs. And that's the pattern which we have to use. So let me get to, so I know I didn't answer it directly, but did I give you enough context to move on?
Thank you.
All right. So for us, UP, we had a good jump start. Like we have a good jump start. We have a very strong platforms foundation. That's literally my background before we started on this journey, is building this API ecosystem. Now, that's why I said we are data rich. Like we have almost everything in real time. Everything operationally, we know what's happening. We know where our assets are. We know, and we have a very modern. Like we just went completely live a month ago. We have a real-time API ecosystem, a transportation management system, which handles planning and operations in real time. So we have about 6,000 microservice APIs in production today. We on our platform we make about 5.7 billion API calls, and we produce about 1.5 to 2 billion real-time events. Like these are not, hey, something happened. Like these are actually really rich events. Like we know a car change state, we know car change location, we know we assign this car to this train, we know this train is at this location. We know these are the work events which happen, and things like that. These are like actually meaty, like real events. It's not just data moving around. There's actually meaningful business events. We've tons of these, all right? And we have a very rich curated ecosystem. So in some ways, we have a strong foundation. Like we had data. So for most people who are starting this, like you have to somehow get to this. And I'm not recommending that go build an API platform first. What I'm saying is that you have to think through data either moves in batch, like how you capture, or it's available in real time. The more real time it is, your inferencing for prescriptive predictive use cases becomes more useful, right? So part of this is that you have to think through how do you get the data which is required for advanced analytics moving and captured and moving in near real time, right? That gets super important as you want to move to the right of the spectrum. Our data strategy at a very high level is about, we were, from a maturity model, we were in kind of hindsight mode, right? Descriptive. And we kind of sort of are good at insights and diagnostics and predictive. We are like where it matters. We're very good. Well, we're very poor when it comes to foresight, right? The prescriptive and to operationalize this data and be predictive about things, right? And that's where our investment came in. Like about 2+ years ago, we went to the board, and this is in a bridged version, a sanitized version of kind of the board slide, which says, all right, for the business to grow and for us to be able to efficiently use the assets we already have and do more, we need to actually get to more predictive and prescriptive mode. And we were sitting, like, since our data rich platform is already there, the pitch to the board was like, okay, we have a solid foundation. This is how we grow. We grow by making our assets more efficient, and for that we need to actually mature in terms of our capabilities to get more predictive and prescriptive in terms of our analytic solutions. And they said, yes, okay. The business benefits are like, okay, it's common sense, right? Like it's that easy. The enablers for this journey is that, we were predominantly, that API ecosystem I showed you in the previous slide, that's all inside the company. Like this is inside our data centers, like it's completely homegrown, right? Like this ecosystem is completely homegrown, right? Everything about this is inside our data centers, right? We built the API platforms, the middleware, the observability stack, like the hosting, everything for this is inside. Now, but we knew that the analytics, when it comes to advanced analytics, that's not going to scale, right? We can't do that. So we had to make sure that, okay, that our solution was cloud powered, right? And so that we decided to build this data insights platform on the cloud. And so part of this journey was like we had to step back and ask and answer to ourselves a whole slew of like basic questions. Like, okay, we had to elevate our own advanced analytics competency, which we didn't have, right? We had analytics competency, but not to do everything else which we wanted to do. And these are all journeys. Like this is not a checkbox which says we're done. So that's what I'm going to walk you through. It's never going to end. But we were on this journey, and we had to establish an effective governance, and we had to step back and think about like how do we shepherd like great stewards for our data? That becomes the foundation for your data products. All right. So a data mesh, my simplest definition, again, and you can ask Bard and Gemini and ChatGPT all these questions, like you probably will get this answer, like very similar, right? So I'm not saying anything new here, but we can have a discussion on it. To me, the data mesh is more of an architecture philosophy than anything concrete. Like you can't go find saying, here's the pattern you should go do. This is more about a philosophy. And you have to have some objective in mind before you go down this path. For us, the objective was, how do we mature and enable our company to be able to do prescriptive and predictive analytics on all of the data which we have in different silos, right? That's a simple definition. For that, we had to step back and think about, all right, how have we structured our data today? And where is our data located? Who has ownership? And how do we democratize this? So data mesh is about integrating these data silos and democratizing the data, right? Like a tight control of a centralized warehouse is not the solution to this. You can have centralized infrastructures. I'm not saying it's like everyone should go have like 20 different implementations of this, but it should not feel like it is centralized control. It has to, because no central team, that's the core principle, no central team can have a ownership of this one. You guys had to keep me honest here, like, okay, so on time, how am I doing on time?
You're doing great, no worries.
Okay.
We have about up to 90 minutes.
Okay.
From the
start. Because I do want to leave enough time for us, the discussions and stuff. Yeah. So
of course, we're keeping an eye on it. Don't worry, you're doing great.
Okay, thank you. The second principle is that collaborative access, and means that the more people should be able to, like today's world, like if you go to the current distributed share analytics world, we have centralized control over everything, right? Like most of the companies, if any of you who have any data warehouse installed, I guarantee that it has centralized control, right? There is a team which actually manages it. There's a data engineering team. There's only one which knows how to go to push data clean this, and they have a tight control over that model. And if you want a new one, you have to work through that thing. and they create these new models for you, and it has and no two business groups can actually share, right? Because you fundamentally different problem models on a single infrastructure. So it's not a collaborative access. And there's very little, I mean, maturity in terms of self-service data products, right? The models which are created today in analytics warehouses are problem-specific models. Like it does one thing really well. It's arranged in some form. Even if you have a very good fact-dimensional model laid out, it's about one problem, right? Like it's not modeled. Very few, I shouldn't say all, very few companies, because would have reached the maturity and like, I need to fundamentally design the domain models of my enterprise. They don't do that. Like none of us, like we don't do it. We didn't do it, right? Like we started with lots of tabular structures which are related to each other, came up with relational concepts. We couldn't even name that thing, but it solved a single problem. I could figure out why did I miss my ETA? So I brought a lot of data together, and I was able to answer the question. Like our analysts were able to run lots of queries and perpetually ask the question. But all the data which we brought together, if we had asked somebody to, can you name, like, what would that domain model, like, can you name that data product? Can you give a name to that thing? They would give a long sentence, right? Well, that's a set of tables which has all of these data, which actually helps us answer these queries. You can't really, right? I mean, say, pause and then think about this, about your own company. Like, think about any warehouse which you have. How many concepts? Like you have a schema name, I give you that. Like, oh, this is train, this is car. But if I double clicked and if you asked yourself, like, okay, can you actually, if you lasso that schema and say, actually give a business definition name, like a product name, you can name it. Most of us cannot. And that's the problem, right? and it's not agile and scalable, right? Like today's data warehouses. I'm giving you the anti-properties, and I'm saying these are the properties which we need to get to, right? It's not scalable, right? Your centralized data warehouses, like our centralized data warehouses, it's not scalable. It's not sustainable at all, right? Most data warehouses are vertically scaled, right? You can add more power to the same vertical stack, but you cannot scale this horizontally, right? Even as a solution stack, right? You just have to instantiate different warehouses all the time, and those things are not agile. Those processes are not agile, right? I already talked about broken silos, right? Broken silos, if you don't break the silos, the insights are locked. It's not free. I guarantee that most of us, at least we don't have empowered users, right? Like we have tight controls over this simply because it's centralized ownership and it has no collaborative access. The first two properties or the first three properties doesn't enable us to empower users. Like we can't unleash people to say, well, I want this product, I can combine this, and I want to run my own business analytics. Can't do that easily, right? So if you truly want to get to the right end of the spectrum on the analytics journey, we got to do all this. This in some level of maturity or not, like you have to get to solving some of these problems, and that's a data mesh journey, right? I'll give you some principles. Like this is our principle, and the reason I write this the way I've written it here is because we learned this the hard way and we made mistakes, and my first three boxes are like lessons learned, right? It's an expensive lesson, right? Costs a lot of money, but that's a good thing about the cooking. Like part of the reason I do these talks and we're doing these workshops is, well, let's make new mistakes. Let's not make the same mistake everybody's made, right? Like we made this mistake. I learned, like we learned from other people's mistakes. And so we didn't make the same mistakes others did on this journey, but we made our own. And so collectively, let's stand on the shoulders of giants and not make the same mistakes, right? So part of this is, the first principle is that don't ever treat this journey Like I want to get to this advanced analytics and I want to deploy AI ML solutions to my company as a, like if that's the end goal of your data mesh journey, as something which is it's not a 90-day project. It won't be. You can probably get to your first AI ML solution quickly, but if you want to leave behind a sustainable ecosystem, so where you can keep churning out a lot of AI and ML, like predictive prescriptive solutions, then you have to treat this as a journey and at various levels of maturity. And you have to break down some and build some basic capabilities. The first thing is like build the capabilities which are essential and focus on the experience. Start with the end in mind. Like and don't shortchange. Like we did this. Like we started thinking about what the end in mind for the end user first. It was kind of a mistake because if you don't have a good foundation, your platform being the foundation of this, you got to think through that experience for like my own team's experience was singularly more important, because if we shortchange the experience at that thing, some of the enablement, like in terms of automation and making it self-service, all that stuff doesn't work, right? Like those are foundational things. So don't skip the platform experience. So keep that end in mind. Like what should your platform team, your engineering team, and the people who enable the rest of the services, what should their experience be? That's the first thing, right? That's a lesson learned. Start with generalists in mind, and people who actually, I say this with a little bit of tongue in cheek here. If someone knows something like way too much about a concept, that they're not the right people to start your data product journey. It's got to be generalists who can actually think through a much broader scope of the problem. If you think about like modeling data products, it's not a set of tables. You ought to be able to say, hey, it's like any other real product. It has a life cycle. Like, what goes into this? And it's a very abstract model for us. Like, I'll give you equipment. Equipment is a rail car, right? And there's so many different types of equipment. There's properties of this equipment. It's those of you who have object-oriented experience, I can think of this as more like a domain modeling exercise, but it's more than that. In this case, you have to actually abstract the behaviors. Think about the behaviors which can happen on this data product, right? The types of questions you're going to ask, and the types of guarantees you need to give, right? It's not a data structure, but it is you have to think through the life cycle of that. So for us, you have to think through if it's a locomotive, if it's an equipment, like what is the life cycle of that? What are the sources which come in and feed this? What would be like different stages of refresh which can happen? How do I guarantee to the end user who's going to rely on this product the immutability of some of these structures? Like how do I evolve this? If I evolve this for the next person, like a version 2.0 of this same data product, how do I not break the version 1.0 constraints, right? It's really key, and there's no simple answer to that thing, and you have to. But the lesson I could honestly say that we need to follow, and because we started with specialists in mind, and we had to walk back and say, no, I think you have to think through it more generalist. Knowing too much about something is actually not lending itself to a good model. It's actually the other way around. Think of this data product as an abstraction. Think of truly as like, oh, you're going to version this. It's going to evolve as your business needs change. That data product is going to evolve. You had to think through that evolution upfront. Like there's a certain set of behaviors and life cycle guarantees you need to give. And the refresh rate, the guarantees, like, can you find this in a catalog? Can you describe what it does in a way? And can you actually align some stewards to this thing? and they have to come not from technology teams like IT teams. They come from the business. They have to be vested, right? And that's when you arrive. So you just start with that end in mind and a very data product as an abstraction, and have a governance model before you design. Like that's your second lesson, right? The last lesson is that start with the platform foundations first, right? Like someone earlier asked me about ETL, right? Like this is you get. So I'm gonna, since you asked me that question, I'm gonna focus on that one. Making that's an architectural a choice you're making. It's a data pipeline architecture choice. Once you kind of make some of those basic decisions, it's reversible. You can't. You had to like break it down and rebuild it again. And so some of those foundations, you have to get that thing right. For instance, like a zero trust model. Like if you, these are not concepts which you can weave in much later. You have to weave this, like think this through beforehand. So when like we're on Azure, we had to go back and rethink like a lot. Everything which we knew about how to do security inside our data centers didn't work exactly. It didn't map 1:1, right? We the controls which we have internally is not exactly the controls which we could actually just overlay on with a hyperscaler, right? The hyperscaler facilities are very different. And so we literally take a step back and say, all right, what is like how do I terraform like a new ecosystem? Like I'm not using the tool named Terraform. Like I'm using like the English word. Like how do I make this cloud ecosystem in a way that I can lay the rest of the building blocks, and I can kind of overlay some of the principles, like starting with zero trust principles, right? And before there's always a tendency, like since I'm an engineer, like most of us engineers, like we want to automate everything, right? Like if I do it one more time, I want to automate it. I don't want to do it again, right? That's almost a fundamental flaw in most of us engineers. And well, our lessons learned is like, okay, learn to do these things manually first before you can automate a process, because you don't know. Like we were surprised by how many processes were different, and where we deployed automation is not the place we could deploy automation, right? All right. So before I get here, like questions, thoughts. This is your tee-ups, like kind of for what the data mesh journey is.
We do have a few questions for you.
Okay.
Gotcha. So earlier, Animal asks, for high throughput data systems, do you rely on open source infrastructure and software or commercial ones? And to learn these, if we don't have much background experience, how can we learn this information?
It's a very good question. The answer is like all of the above, right? Like we use open source heavily, and there is one slide. Actually, if you hold for like 2 slides, I think 3 slides, I show you the stack, the actual technology stack to do this. So I'll hold, and to learn this, if you do not have access to too much, what is Gian? What is Gian systems? I don't know what that means. If you do not have access to much Gian systems, how do we learn them? Okay. In fact, even if it's commercial, like so let me guess at this question, part of this question, and answer this. Open source or commercial, there is the vendors have all the incentive to make this easy to use and easy to learn. It's already there, right? Whether you use, like if it's you're deploying in Azure, or you're using their data fabric, or you're using Snowflake, or you're using Databricks and whatnot, like all of the vendors have enormous amount of training and documentation. The flip side, the real question is that how do you know which one to use? Like that's the real question, right? Like it's not so much like you pick up one tool. I'll show you what it takes to actually build a stack like this. It's a assembly of a very complex stack. So part of your question there is that can one person learn left to right everything? Absolutely not. So this gets fairly expensive and siloed in terms of expertise. Like your data engineering team, what they use is very different than what your data science team would use. And they might use the same ecosystem. Like they could use Databricks as a tool for data science and for data engineering, but your data engineers will probably want Spark expertise, as your data science people probably want how to do model tuning. It's they like a single person will not have both. It's very rare, right? Did I answer your question? Is that? But I'll show you the stack when we come there. Okay, I'm reading the next question here. I'm afraid of data security, privacy, data quality in cases of decentralized ownership and collaborative access. Hold that thought. I have a full slide and we can discuss that. You should be, let me answer this. You should be deathly afraid of all of those. But decentralized like this, let me answer just one point. The decentralized ownership doesn't mean decentralized access control. Like, so part of this of building a zero trust foundation is to think that through how do you grant access? How do you keep track of who has access to what? How do you automate that process? So you had to think that through from ground up. The data quality issue, to some extent, is how you build the pipelines, like, and how you design your data products. The data quality will fail the first few times. Like so none of us are going to get this thing right first, but you had to get the data security right the very first time. Otherwise, your data will leak. The other ones you will learn. It's an iterative process. But so I'll get to that in my data governance and security slide. Okay, so I think part of the question is like, how do we learn some of these tools, and if we can't access them on our laptops? You can access a lot of them, but a lot of that is SaaS software, right? Like it's very little you can do on your own laptops anymore. I mean, I can run inferencing on my Mac here, like, you know, I can run a model. I can run, I can run a Llama 2 index on this machine and it works fine. But the whole ecosystem to fine tune it, I can't run it. It's impossible to run on. So some of this, like, you have to leverage the cloud provider. Cloud providers have a lot of open access. All the three primary hyperscalers in the world have they give you enough free accounts or very cheap accounts to go try out everything, because it's in their best interest to get a large ecosystem of people using and driving their tools. So it's there. All right, I think is there any other question? Yes, Mina?
No, sir, I think you're ready to progress.
Okay.
Thank you so much.
Sure. All right, so this comes to the heart of the first question someone asked me about ETLs. So the very first thing we have to think through in a data mesh journey is that you have to think about 4 different silos. And you had to clearly build out these silos. In the past, like we would build the capture, move, and curate. Like that's the ETL, extract, transform, load. Curate was transform, and load was kind of move. Where like one thing, it was usually concentrated on a single tool, and the tool drove this pattern. If you truly want to get to like a ecosystem which can sustain real-time events to allow you to do real-time stream processing and allow you to do real-time decision making, which is where the prescriptive predictive use cases, what they need, you got to get to really break this down into 4 different things. And as soon as you start thinking of these 4 buckets as completely different things, it frees you from tooling. You can apply different tooling and different architectures and different patterns for each step. And each step is independent of each other. It means that you can change out things in each of these things. So for instance, like capture from your run the business stores or eventing streams is an independent step. As soon as you make it independent, it has, and from how somebody is going to use it, all the mechanisms are not tied to a business use case. It's just literally about how do I move a large quantities of data on a timely basis in an error-free manner and build out all of the non-functional requirements of guarantees and for capture, right? And then so that becomes a very clear data engineering only. Like no data scientist needed, no business analyst needed. Like you just need data engineers, right? Like people who wear that hat. And then you can start deploying automation. You can literally think through the different engineering. Otherwise, like, well, in our current ecosystem, like in a previous ecosystem, it's all tied to operational systems. Like the engineers who built the OLTP systems also built some of the ETLs. Like so they built their own extracts, and because they wanted to dump it quickly because somebody asked them for. The business users wanted data somewhere. The capture mechanisms work completely custom to different groups. You don't want that, right? That's not scalable. Moving the data, like it's a separate, like you would think that capture and move, aren't they the same things? Actually, they're not. The capture is about like defining at the edges of your run the business systems. How do I actually, without actually causing harm to the running systems, how do I actually just extract data from it? Like, how do I just capture, right? And so it's very much depend on the technology which is used, the data technologies which is used on your OLTP systems. So let's make it concrete, right? Like, okay, if you want to capture from Oracle databases, that's it that your company uses, and we have thousands of Oracle databases, right, in production, and you want to capture this from Oracle, you don't go and then say, ask every team, all right, hey, I want to extract this, like, tell me what your model is, tell me, can I put a trigger, store procedure, can I deploy something in there, like, can I use whatever Oracle tools, and we tie it to the build cycles of that operational systems, right? Instead, if you say, well, if the target system for capture is Oracle databases, there are tools, patterns, and mechanisms to capture from redo logs. Right? Oracle gives you extracts, and they're tool providers, and I'll show you some of them, which we use. Or that's. I'm not recommending the same tools you guys should use. I'm just saying this is a sample you could use. The capture becomes completely independent. At that point, all you're worrying about is that can I have a guaranteed capture? Like if something fails on the source system, I can build out all of the mechanisms to say, all right, how do I restart this? How do I capture this again? How do I make sure that, okay, this stream which went away, when it comes back, can I pick back the guarantees of capture? Like you can guarantee each of these verticals, you can actually have non-functional requirements, well-defined, and the team knows it. And it's very technology driven. Oh, you're capturing from Teradata or SQL Server. Okay, well, that's a different capture mechanism. Is designed for it. If you Oracle databases is designed for it. If you have Solar or Hadoop or any of this big data stores or document stores, you have a capture mechanism. So you're not tying it to a business problem. You're tying it to the technology. So the first step is very much technology centric. The move is also very technology centric. It's engineered infrastructure, right? To move large quantities of data. So some of it, like if you move really large quantities of data, you have to rethink some of your networking too, right? If you're moving from your data centers to cloud providers, do you have even enough capacity, like on your dedicated links? If you like, we have our own private links to the hyperscalers, and it means that I mean, obviously we didn't lay the fiber all the way out, and we use carrier hotels, and our networking gears live in carrier hotels, and then which connects to the hyperscalers. So from our data center, we push data on our private network to the carrier hotels, and they're largely distributed across the country. And then from there, the data moves into the hyperscalers, and that's a secure private link, right? And so you had to think through, all right, you could use that mechanism, or you could just use internet plane as the mechanism to move data. All of these are considerations. And moving data from one place to another is a set of engineering tasks, and they are independent, and you need to think about this separately. So you cannot just click, drag and drop and say, well, from this database to that database. You had to think through, how does the data flow, right? From your capture mechanisms, and so that's engineered infrastructure. You had to think about this completely separately. If you're especially doing real-time streaming, like capturing real-time streams, it becomes fairly important to think through, well, what does the cloud provider have in terms of handling streams? Like, where would you do like the first layer of curation, right? Like, so if you, before you do that curation, like, so you have to make sure that the data is moved over there correctly, like from the capture to the curation lakes. So moving is a very important piece of the puzzle. So it's not part of the capture. You have to think about it separately. Curation is where the first level of cleaning happens. Like if you want to produce clean data products, curation means that you land a lot of data like really fast, allow specialized mechanisms to pull and actually either enhance them, enrich them, clean out, dedupe them. Like, that there are data hygiene tasks which you have to do, and you have to do this in a separate ecosystem. So don't tie this again to the moving and capture, right? So whomever asked me about the ETL, right? Like in this case, I literally reversed this. I'm describing like breaking up this ETL into like different steps, a completely different engineering concerns. And and when you asked about Power BI and Tableau, to me, they are in the fourth bucket. It's more of a user tool than the first three, right? That's where some of the insights exploration, like reporting, and some of the transformations happen, but that's very business specific transformations, like that's problem specific transformations. That's where you would use that tool, right? If you notice in the bottom that I have two boxes, like data engineering has a role in all four buckets. The kind of the data governance steps, like the handoffs is after the capture. We separate the capture, that becomes engineering. And so we'll talk about that one, right? Like it's an oversimplified architecture picture. And I'll let you guys like kind of grok this for a few seconds before I talk about this. And tell me if this makes sense. Because I'm going to use this as a template for the rest of my talk. Promise I won't bore you for more than 20 minutes from now on. So. And I have a for HANA, like we didn't talk about Gen AI when I did this talk in Georgia Tech, but I have a couple of slides about how does Gen AI, like the generative AI, fit in a data mesh journey as at the ending of this talk. So
That
I will
would be
bolt on.
fantastic. Yeah.
Yeah.
Everybody's interested in Gen AI.
Yeah. So there's 3 segments to this journey. The blue journey is about data engineering, right? And then the green portion of the journey is your MLOps pipeline, right? And then kind of the orangish fork is the reporting and analytics. In most companies, it's the orange line is what we traditionally have today. And we have KPI dashboards, ad hoc analytics. That's what we have, right? And the blue data engineering is kind of very custom to each solution. There's a blue line, like all of these blue lines, very custom to a problem in the orange lines. So part of the things which we had to think about in this approach is like you have to think about this as 3 separate journeys. And clearly articulate, like you had to segment it from team, ownership, like and basically how you lay out a solution stack. You had to think about it this way. Does anybody have any questions before, like on this template? I can answer this now and then because I'm going to use the exact same thing.
I don't see. Oh, actually, we do have another question. Out of these 3 lines, which one do you think has more stability and promising career in the future?
All 3. Well, okay, I wouldn't say all 3. I would say the blue and the green lines, right? The orange line is extremely important. It's not going to go away. You know, these are what, like the bottom lines is where your CFO lives, right? Like that's like you got to guarantee, like, you know, your Wall Street reports come out of that one. So or for us, like, you know, we produce a lot of industry metrics. We and we had to guarantee them. Like, you know, you can't have a twinge in them, and they had to be rock solid. So all 3 of them will exist. Like the blue and the green is kind of new, right? And that's a good question. Like, okay, it's not very many people will jump into on day one into the orange lines, but that's where a lot of your business actually is using today. 80% of everything which happens is in that orange line. So all 3, but if you're looking for new and cool, that's the green line and the blue and the green lines. So someone asked me about technology stack. This is our, I am not recommending, so I'm not recommending any of these products. You can swap a lot of these products. So so this is a deployment of the technology stack and something we have used. Right? Then we've asked the vendors if I could put their logos on them, and yes, right. So the data sources are internal sources. These are run the business systems, right? Like the one which I have there called Net Control is that API platform. That 6,000 APIs kind of lives in that thing. CADEX, PTC, like, you know, these are our internal operations system, right? So those are our data sources. So the CDC is change data capture. Remember I said one of the steps is capture. Like it was a clearly defined step called capture. And we use some of these tools. Like it's defined, it's not tied to, it's purely a technology play. And moving the data, right? That's the enterprise load pipeline. We use, Kafka backbones, like a very large clusters of Kafka backbones. We use Confluence Cloud. We use Azure Event Hub and a whole bunch of Azure tech out there. and we built our own some of those, some things. You can use, someone asked me like, okay, why didn't we use open source? We use Kafka open source and also the Confluent branded Kafka. I mean, we have a very large footprint of the open source one also. But there's some Cloud Connect, which they bring as part of their paid subscription, which we didn't want to build ourselves. So we bought it. So it's a combination of build and buy. There's a lot of things open source underneath it. I haven't put all the icons on this, just the high level ones. Like we have our own Spark clusters. Like we don't use like the paid version from Databricks. We have our own. We have our own Flink processing pipeline ecosystem. Again, so these are all open sources. So if someone asked me like, okay, what open sources are you using? We're using this. And they all go into this, into these buckets. That's where they live. So curation data lakes, you had to make some choices very quickly. Like you had to pick. You can't kind of work your way up and say, well, I incrementally add this. You kind of have to have some map of what a final looks like. You may not have all the products picked out, but you got to have this map laid out. Because it drives a lot of the decisions afterwards, and they are very costly to reverse as you get forward. Alex, this one is our data catalog product. So if you notice that I use the same product, someone asked me about the centralized and decentralized, right? Like, okay, I have a centralized, cloud data warehouse called Snowflake. I also have a data warehouse and an ML compute platform called Databricks, right? And I also have Azure, like set of components like Azure Data Fabric, and then they're eventing patch components also. Like if you looked at a single vendor, they offer all of it. It gets tricky to just use one. Over time, that you have to pick what is the right one for the right things. And this is after several tries, and it took us a while to actually get here.
Arun, if I may ask a question.
Sure.
So you have Alex, pretty much that's your metadata repository, or Alex in the middle, and you called it data catalog. Can you elaborate on that a little bit? And it cuts across all of your analytical platforms
and transactional platforms. So it captures. So Alex is our data catalog. It also tracks our lineage of this. It is also one of the foundations of our governance. So we drive data governance through it. So it has all the metadata about all the data sources. Like how is data moving from? So data is moving on this picture from left to right. So it captures the lineage, the ontology, the sources, and the metadata about and where is what, right? Okay, hey, this data is actually now is spread into these models in these schemas, is replicated or it not replicated, but data moves in, right? People take it and reshape it and move it into different schemas. Like, so you want to capture that lineage. That's what we use Alex for. So there's enough automation we built. The product comes with automation, but we also built automation to capture some of those things. The other product in that space for HANA is Collibra. Like most of the companies, you would use Collibra, right? We looked at all and we landed here.
Got it.
All right, let's get to zero trust, right? Someone asked me about this. So you had to first think about where does trust start? There's two types of trust. Like one in your transaction system, like it has trust, right? Like you guys have built whatever it is that we built, we have controls over this. Let's assume that we have controls over this. When it comes to this analytics system, you have to make sure that okay, the trust boundary extends all the way up to the load pipelines. Like that is, most people would say, hey, the trust is only in the data store. Like, you know, if you just design Snowflake schemas and access and like since we were using Snowflake, well, that's like I can guarantee all of the guarantees, like which about data security. That's not true. So you have to build for every handshake of data in this step. You have to make sure that you don't trust it. So the zero trust principle is I trust nothing. I verify everything. Right? If it hops something, a boundary, a virtual physical boundary, then you have to reestablish trust. That's a zero trust. So you have to extend this all the way to the beginning of your enterprise, like where data is actually captured and moving, like beyond your capture schemes. Because until then, you have other guarantees, which is the same guarantees as your OLTP systems. Once you pull it up, then you have to make sure that, okay, the trust boundaries is that wide. And you have to make sure that every hop, like on every transformation that you're carrying in a metadata, like you have built-in controls and checks to have identity checks. Are you authorized? Like whether it's software, human, like it doesn't matter, like who has access to this. You have to make sure that, okay, that is an authorized access. It's kind of, you have to think this through. You can't bolt this on. It's a lessons learned for us too, right? That the first overlay we did very quickly, we had to go and redo because we didn't think through how would we provision the users on top of this, right? Like it didn't work out all that well for us, and so we had to think this through. Ask me questions here, like, okay, so since this is the security slide and it's fairly conceptual, I'm sure that, okay, this people might have questions. Or I'll move on. It's kind of hard to make this concrete without like beyond this one. And it's kind of a lessons learned. You have to make sure that at least if you one takeaway from this is like every line which I've drawn there, right? Assume that you need to have an identity check. Like, is this authorized? Data is moving from left to right on this, like still already following this path. You got to test, like your identity management system and the way you're provisioning access has to guarantee that you can verify. Because you will hop, like the way I've drawn that brown line is where the cloud boundary is. right? It's leaving my data center and moving into the cloud. So I don't trust it. Like you cannot trust it. And so you have to verify integrity of access, integrity of the data frames. It's more than just guaranteeing the bits and bytes got there. Like as you move to the right, you have to start conceptually guaranteeing like your data is actually correct. And the right people or software has the access to do whatever it needs to do. All right, so this is the green portion of the arc I had there, right? The MLOps pipeline, it's it's like DevOps, but it is different. It's because you have to guarantee the life cycle of your data products. So let's define kind of what it is, right? Like in a DevOps pipeline, you have to guarantee, like, keep track of your code, right? Like your source code, right? Like, hey, it came from a developer, somebody checked in, it hit an automated DevOps pipeline, your Jenkins or GitHub pipeline picked it up. Like it did the compilation, packaging, and then it deployed to a target system, and containerized it, deployed it, target system. And the change and the access management was built into your pipeline. And that was source code. And once your source code hits production, it has access to data and it did something. But you could always answer the question of, hey, how did this code get here? Like, who kicked off the pipeline? When did it get there? Like what paths it took? And then if you have to undeploy and go to a different tag, you can do that. Like that's your classic DevOps pipeline. With an MLOps, you have to now guarantee that your model was trained on a certain set of data sets. Like these are data products which it actually relied upon. You have to now guarantee the integrity of both together, right? If you think of your models as your code products, it's only half, right? Like it requires your data set underneath it to be lockstep with it. So if you evolve these products independently, you have to also have to evolve this. So part of the extensions you have to think through is that how do you actually guarantee? This is where some of our cataloging tools help, like, okay, keep track of the data products, the versions which was used, what sources were used. You should be able to guarantee that, okay, these are the sources I used for training, and these are the streams, and these are the products which is actually pulling for inferencing later on time. So you had to think that, I'm not saying this is very complex. I mean, but you have to make a conscious effort to go design that MLOps pipeline that way. The second thing which is different is training and inferencing are completely distinct steps, right? Like we're worrying about the inferencing step, right? Like that's where the answers are. Like you want to throw questions at it and it needs to answer. But it's during training and usage is where the data products is more useful. So I'll pause here, like, because I think you can ask lots of questions on go different places with this. Is there any questions on this, or was this clear enough? All right, we can come back to this in the end. All right, let me take you guys governance. The way I think about governance is like the 3 zones of governance that are completely different. Data governance is not one thing, especially if you're on a data mesh, like a modern data mesh journey. You have to think about this as 3 separate things. One, so I've drawn boxes, like 3 boxes, right? There's the blue box, the data engineering governance is about technology. That's what let me step back a second. In today's world, it was just one thing. IT teams pretty much did data governance. Like they were in the center of the thing, and we invited a whole bunch of people, and we all talked, and then and data governance happened. I'm oversimplifying it, but that's kind of how it works. It's a centralized model. In a decentralized model, you break out like concerns to different people. The first thing is your blue boxes, or like that's technology team, that's IT. It's got nothing to do with users, right? Like the users, we guarantee that the data cleansing, the capture, moving, cleansing. It requires rigidity and set of governances. We guarantee that that what we're landing in the curation data lakes, and is clean, and we can stand behind it, and we can guarantee like whatever the SLAs we promised. And to that effect, that's the extent of governance, right? The orange box is extremely rigid because this is operating and reporting and analytics, and means these are traditional schemas. Like this is traditional data marts, like what we have today, like data warehouses, has to be guaranteed. Like we need to know where data came from, like what sources they use, and absolutely guaranteed because these are like what we would produce: operational reports, industry reports, financial reports, and this can be life or death, right? Like the answers can't be wrong. And so the governance steps is very different, and it's very problem specific, and the people who govern this are very different, have a different set of concerns. The top portion is the actual data products, right? Like the modern day version of the domain models, and which has a different life cycle. This is where the green box is, where the stakeholder is a business. The green box is semi-rigid, right? The orange thing is very rigid, and the blue thing is rigid, but it's completely driven by the technology teams. The top portion is where the business, this is where the decentralization, the democratization is happening. They drive it. Like the IT team is just a participant, right? To get to that, it's kind of hard, but we had to start there. Like, for us, it's not like we got this right. And I am not saying that we are wildly successful, but we're getting there now, right? Like it's a realization. We had to step back a bunch of times, and now we're like, oh, okay, that's where the business participation is, and we're starting to have these abstract conversations about, oh, what is an equipment look like? What is an equipment's life cycle like? So maybe that is a domain model. So those conversations is what's happening in the green box. For all of this, your discovery portal, like I mentioned Alex as one tool. A discovery portal is something which unifies all three. So this is a product we're developing on top of Alex and other custom tools, so that we can give our user experience to all three categories of users the same experience. You should be able to search, you should be able to answer who, what, where it come from, right? The lineage questions, and then be able to support some of the governance processes. That's the part of the discovery portal. All right. So till now, we just talked about traditional data mesh. And then I know most people are asking, okay, you kind of talked about AI ML on the green bars. Like, what about Gen AI? All right. It looks different. I picked this from a slide from DataGrids. They had this maturity model, and I like this very much because they had this iterative, like evolutionary path, a Gen AI maturity journey, and it kind of explains like this. So let me spend a few seconds on this. Right, there's 4 buckets of generative AI solutions, like in terms of a maturity model. Like you can do basic prompt engineering, like kind of what do we do with ChatGPT and OpenAI, right? You can take any pre-built models, which is crafted for a problem space, and then use just any large language model and specialized prompts. And right, like you can have a conversation with it, like the most chatbot-y things, right? That's prompt engineering. So it can do certain things like pre-programmed tasks and uses natural language interfaces. Perfect. That's where I recommend that everybody start, right? The second one is that, well, obviously the first one is going to hallucinate a lot, and it's not going to be very understanding of your business domain knowledge. And this is where RAGs come in. RAG is a technique called retrieval augmented generation, which you can apply where you can inject context in the conversation you're having with the large language model, right? So that you can eliminate to a large extent some of the hallucination, and it can give you answers which are relevant to your business. So you're injecting in the conversation your business context. And I don't have time to actually show you what a RAG deployment looks like, but if I do have a few minutes and someone wants, I could show you one of the vendors layout. They have a clear picture, but think about RAGs as specialized implementations, which does not have to retrain any models. You can just use simple vector indexes, index your data, and create vector embeddings, and inject this inside the conversations you're having with your chatbot interface. The third one is actually fine-tuning a model, like taking a base model, a large language model, and tuning it, like you actually changing the weights of the model and tuning it with your data. This requires large amount of custom data and some good expertise. It's very hard to get there on day one. I'm not saying it's impossible, but it's much harder. Most companies shouldn't jump into fine tuning. We're not jumping into fine tuning right now. Like we kind of sort of know, and we know that we're going to stick with RAGs for now, right? And pre-training is Google's other world, right? Like there's only a few people who can go do that. All right. So the same data mesh, like the picture, if I overlaid like how Gen AI fits in, like this is how it fits in. Your data engineering pipeline is exactly the same, remains the same, but you bolt on. And if you notice that this thing stands alone, like separately from the other two journeys. And that's kind of the aha moment for like most is like, oh, well, is it an AI product? If you just want to use generative AI solutions, if you just need this, you don't need you can tune, like take data products from here and use it for your fine tuning. So there's a dotted line. Imagine a dotted line here, but it's more of a dotted line. Like this journey is completely independent. Unless you get to like advanced fine tuning, like you take a model and want to tune it with like my business, and most businesses don't have that much data to train and tune, unless you're a very large corporation, but that's where this ends, right?
Arun,
Yes.
question for a second, please. So going back to, yes, this slide.
Mm-hmm.
This is an amazing conceptual model, but is there any way we can use an example, maybe that UP is using, how you're using Gen AI into this whole thing? So the external knowledge base, what does that mean, and how are we training the models with it?
So external knowledge base is, so I can talk about a few examples of what we're doing, right? So one of the things is we are, so let me talk about, like the first is a prompt engineering solution. What we have is that we've taken a closed source model and a large language model called, one of them, it's a GPT 3.5 Turbo from Azure. and we deployed ourselves. So we kind of built our own ChatGPT using that model. And the reason is that, okay, we didn't want our data to leak outside, so we created our own, and we had all the building blocks in Azure to take that and do that. And you have several models out there, and putting together that simple user interface, interact with your model, is fairly easy. That's what we did, the first one. All right, and then so that's solving a bunch of problems. Like, people are summarizing emails and generating PowerPoints and, writing internal blogs and memos and, reading articles, like whatever it's within the UP sphere, even the external data they're bringing in, they can just plug it in. But it doesn't leave the UP's Azure tenant, like it stays inside UP. So there's no data leakage. And we applied all the governance principles. The second one is the RAG applications are things which we're dabbling in right now. And the reason I use dabbling is because like none of them, 90%, 99% of the time, none of them will reach production. Like you have to, because part of this is about science. Like you try it out, and we get very close to the end, and we realize, okay, well, that's not exactly answering all the questions because there's errors in it, and so you have to go back and try something else. So we have a few which we're trying out. What we've done is like when I say external knowledge base, it's still internal UP data. Like for instance, we have contracts and legal documents and claims and whatnot, agreements. And we take them and then we index them inside a vector index stores. Different vendors, like actually I have this. It's just a purple line, like exploded up. Different vendors, like Azure, Databricks, Snowflake. You can use all of them. The reason, and if you pick one of them, integrating with the other providers becomes tricky. So you have to be careful what you pick. But for this discussion, we picked one of the things we picked is Databricks, right? And the second one we are trying is in Azure. Like there's two solutions, and one we're using a full Azure stack. Another one is Databricks stack on Azure. So we took some of our internal documents, legal documents, and all that stuff, and we just fed it through index stores, and we start tuning those indexes. So what it's allowing us to do is now, as we kind of the same ChatGPT interface, like to a narrow set of users, we're asking like actual claims questions, safety questions, internal users, and it's actually part of the retrieval is actually coming from the vector stores. So so we quickly say, all right, this question's like, what's the relevant documents, relevant contracts, agreements, which map to this question. We pulled it up, and then we feed it to the large language model and say, now build me a real Englishy answer to this. And that's how that's why it's retrieval augmented generation. It's kind of what we're doing.
Perfect, thank you. One of the participants asked about a career question. I know that's prevalent on everyone's mind, that which career paths would be the most lucrative ones. I would say, would you agree with me that the combination of Gen AI with data meshing and all things data science would be the gold in the next couple of years? The way you've done it at UP is a prime example of how it should be done or is being done.
This is lessons learned from other people, right? Like, okay, so we didn't invent all of this. So we borrowed lots of knowledge and lessons from other people. You're absolutely right, Farhana. So the blue line, green line, the pink line is where a lot of the innovation is happening. Don't discount data engineering. There's a lot of things which is happening in the data engineering sphere. And it's one of the reasons why I clearly separate that out, because it's a there's no single person who will have all three disciplines. Like it's nearly impossible to specialize. And so you need all three. you can't go wrong. There's a lot of changes which are happening, fascinating things which are happening in the pink line, like the generative AI, and especially AI. So I haven't even touched on like some of the things we are looking at is AI for optimization, right? Like we talked when you and I met in Georgia Tech. They don't follow in this line; they actually follow right here, like about this one, right? There is a lot more happening in this world, in these blue, green, and pink world. You can't go wrong from a career point of view.
Thank you.
So this is just it's complex orchestration, right? Like I tied all of this together in one place, like all of the pieces of the puzzle which we use. So let me sum this up. You got to think about your data mesh building blocks as it has to. For us, the guiding principle was that we want to grow as a company. We weren't doing this because we wanted to get the AI and ML. We're doing this because growth required us to leverage predictive and prescriptive capabilities so that we could optimize our assets more efficiently, like do more with less. That was our goal. And then so we had to step back and think about traditional analytics doesn't support this. We had to come back and say, all right, how do we rethink this? A data democratization journey means that we need to start thinking about data as products. These are enterprise repository of knowledge, right? That has to be curated. It has to be managed as a first class product. Like it has the life cycle management is not just about schema management. Like it's just tables and rows and columns is not a data product. It's like you have to be able to define it. It should have a purpose. It should have a life cycle, like steps like versioning, evolution steps, and who has who's the steward of this? Like who are the people who can be the from the business point of view? And it has to be this is a lesson learned, value driven. It means that you have to earn the burn. It's an iterative journey, and I told you it's not a 90-day project. You can't get to your first. You can get to your toy projects quickly, but real projects, you have to earn the burn. So it has to be like however we build this, it has to be agile and iterative, and you have to start earning the burn. The burn is a cash burn, right? Like initial investments are huge. Like the cost can quickly get out of hand on this one even for large enterprises. And so part of the learning was like, okay, we have to think through how do we deploy enough solutions which is showing benefits and so we earn the burn which we are making. So it's a different mindset, and it does require some upfront thinking and design, and actually bringing the stakeholders to the table way upfront, even before anything is built, right? Like that's the harder part. A platform approach, like you can't shortchange the building blocks, and there's tons of industry best practices out there. Like the one which I am talking to is like treat this as an industry best practice, right? It's not completely cooked up by us. It's we leverage other people's knowledge and we built on top of this. MLOps, it's any more that doing it internally is futile, right? Like okay, it is a cloud-centric data science ecosystem. So integrating between your current ecosystem into a cloud-centric ecosystem is hard. So elevating your DevOps, DevSecOps practice to the MLOps level on the cloud platforms is key. And collaboration, right? Like okay, industry and research can't do this alone. It takes the whole world to keep this moving. All right, I'm gonna pause here. Like I could take questions. Was this useful? comments, feedback? Or which slide do you want me to stop on? So for questions, maybe this one.
Absolutely useful. We find our participants on the shy side, so don't expect a lot of verbal answers. They do provide amazing feedback, so which we are going to share with you in a couple of days.
Perfect. Farhana, was this something which, like, from the talk you heard in Georgia Tech to hear, like, okay, did this change your mind on any of these? Like, I know you and I talked briefly after that.
It exceeded my expectations. I mean, I had preliminary understanding of what data meshing was, which was really novel to me. And from there to like really paying attention and digging deep, I thought I learned way more than before. And also the addition of the Gen I part is gonna pique everyone's interest, I'm pretty sure. Our participants, the ones that are here, are pretty serious. I mean, they've been here since day one, and they're attending and taking notes and learning. I know that they're going to appreciate it really, really a lot. But I would love for you guys to talk and encourage Arun for his amazing presentation and ask him to come back. I know which you will.
I will come back. There's other topics if you guys want, I can do. I'm very passionate about API ecosystems, as it's been 12 years of my journey. So if anyone wants to understand microservices and building API platforms from ground up, I'm your guy.
Yeah, I mean, I'm looking at all the attendees here. One of the ones that I know the system architecture is at BRAC IT in Bangladesh. I know that they have a great data infrastructure going on, but this will definitely help them out. And if they're willing to talk about it, they're welcome to. And others I'm not too familiar with, but yeah, that was pretty impressive to see it in Bangladesh that they were doing it. But a lot of opportunities to grow.
I would also like to introduce you. I'll send you an email with another amazing person, a partner of mine. She used to work for me before. She just started a venture on her own called Stephanie, and I'll introduce you. A big portion of this journey, like, she helped lead. So another great female leader. So I will introduce. I invited her, like, okay, she couldn't get here today, since it's.
That would be great, Arun. Oh, today's especially your presentation is really more attractive because you have that industry experience, and this is something you've built from scratch on your own. And this is a lot of our early professionals are interested in this. They want to know, they want to learn how to do this. And, you know, also I would love for you to think about what ways they can help you to, and also you can help them gain some domain knowledge. If there are like off-end projects or there are other freelancing opportunities or internships that you can think of that you want to delegate out to them, they would love to do this.
Okay.
You know, we get that kind of requests all the time. And also a large part of our participants come from Syria and Turkey and also Pakistan, and which I don't see a lot of them here today, but yeah, they would love to hear this as well.
Happy to help. Yeah.
Perfect. I shouldn't be doing all the talking. Hey, guys, if you and I know
watching you interact.
Yeah, Yasmina has been amazing, and she just graduated with her master's from Georgia State.
Nice.
And yes, and she did data science, cybersecurity, and criminal justice, and I'm very proud of her.
A little AI.
Very nice.
Very gentle. I did a lot of like AI when it comes to fraud. Besides that, I can't interrupt you, Farhana. I love when you ask questions. I think you ask such detailed ones. But thank you so much, Arun. I learned so much. It was something I kind of struggle with more technical information, but I feel like I was able to follow through today, which was just really wonderful. And I greatly appreciate you.
Well, thank you guys. Thank you.
Very quickly to our audience, if everyone could just turn on their cameras so that we can take a screenshot. So you guys know the drill, cameras on, and then a member of our team will jump to our screenshot. If you could all just look into the camera and smile for just a moment. Thank you.
Smiling too much.
Yep.
Like, all right. Perfect.
All right, we're all taken care of.
Thank you guys.
Arun,
this is amazing.
Before you leave off, there is another person I would love for you to meet is Dr. Desiree Cox. She is this unbelievable trailblazer working out of the Bahamas. She's an MD PhD and working on actually combining art with regenerative diseases. And Dr. Cox, please correct me if I'm not saying it right, so not using the right terms. And she is someone who I would love for you to be connected with because she's doing some really groundbreaking work in
I'd love to.
healthcare,
I'd love to talk to her.
where I think that you'll be able to help her thinking through the whole data process. And we are partnering on a few cool stuff together at the end of the year. So that would be great.
Yes, I would love to do that, Farhana.
Perfect.
If you introduce me, then maybe we could connect them.
I will do a quick email introduction with you guys. All right. Thank you so much. If Yasmina, take it over, do your things. And thank you, Arun, again. I will.
Thank you. Thank you, Farhana. Thank you, Yasmina. Thank you, guys.
On behalf of our audience, we want to, of course, thank you for your time, and we learned so much. We're so greatly appreciative of everything you do. As for the rest of our audience, please make sure to fill out our feedback form. Once again, we want to make these sessions as useful to you all as possible, and we can only do that with your input. Thank you all for your steady attendance and for always asking very interactive questions. It means a lot to us. But of course, thank you so much, Arun.
Thank you, guys.
Any questions? We'll be staying for a little longer. Besides that, you are all free to go. Good night or good afternoon, wherever you are in the world.
Good night.
We'll be keeping the call on for just another couple of minutes. So if you guys have any questions for me, you can leave it in the chat. If not, I'll see you at our next upcoming session. We have a student from MIT speaking, or actually a research associate from MIT speaking this Friday, which is very exciting. All right.